Ever see a crazy molecule name and wonder what it means? Today, we're decoding IUPAC nomenclature.
Yeah, this looks kind of scary, right? But don't worry, there's a simple, logical system behind it.
You can think of it like learning a language. Let's start with the basics and build from there. Okay, every name starts with two simple steps. First step, find the longest chain of connected carbons. So this chain, it's got 2 carbons, and the root name for 2 is always F. See those single bonds? That makes it an alkane. So we're going to end the name with ane. Put them together and you get ethane. Easy, right? Okay, now let's make it more interesting.
Now, if you see a double bond, the ending becomes -ene, and for triple bond, it's -ine.
But what about molecules that aren't just a straight line? We call these attachments substituents. In this one, our main chain has 4 carbons. That's butane. That little branch is a methyl group. So why do we call it 2-methylbutane and not 3? Well, there's a really important rule for numbering. It's simple. You always number the chain to give that attached group the lowest possible number. And don't forget the punctuation. Use dashes between numbers and letters and commas between 2 numbers. All right, let's talk about the real game changers. Functional groups. These guys are a big deal.
Some groups are just prefixes, like halogens, but others, like alcohols, change the whole end of the name.
Take butanol, for example. That all suffix tells you it's an alcohol, replacing the E from butane. If you've got multiple groups, you need a priority list. The highest priority group gets the lowest number. So back to this molecule. The acid group is number 1 on our list, so we start counting there. And that means the chlorine is on carbon 4. The acid's priority rules even if another number seems lower. Now for a super common mistake. The longest chain isn't always the one that's written horizontally. So you might look at this and see a 6-carbon chain, but nope, that's actually not right. If you actually follow the chain around that corner, you'll see it's 7 carbons long, a heptane. So let's recap the whole process. Find the main chain, find the priority group, number it, and assemble. Okay, you've got the tools. Take a look at this final challenge. What do you think its name is?